VMware never ceases to innovate. New with vSphere 7, you have improvements to Distributed Resource Scheduler. In fact, some really major improvements, starting off with new DRS logic. In the past, DRS worked to balance your clusters and would really only make changes if a workload on a virtual machine wasn't receiving the resources that it needed. New with vSphere 7, DRS is now what they call workload-centric, and that means that the role of DRS isn't really to balance the cluster. The role of DRS is to ensure that your workloads are happy, and that's what this new VM DRS score is. Every virtual machine is going to receive a score that essentially measures how happy that virtual machine and that workload is. If the virtual machine isn't as happy as it needs to be, and if the cost to migrate that virtual machine to another host where it could be happier isn't too high, DRS will take action. We'll learn more about the new DRS score in the next lesson. Another new feature is scalable shares. We'll talk more about scalable shares for DRS in an upcoming lesson. But the idea is that your virtual machines that have a share level of high will be prioritized over other lower virtual machine share entitlements. And finally, there's an improved user interface around all of this, so you can easily sort on the resources that a virtual machine is receiving, where it might be lacking in resources, and what the virtual machine scores are. So with that, let's talk now more about the new virtual machine DRS score. I must say that I really like the new VM DRS score concept in vSphere 7. The idea here is that 100% score means that your virtual machines are super happy, and anything lower than that, their happiness level is decreasing. If you get down close to 0, you've got a major performance problem. It's a very quick and easy way to see if your workloads are happy and performing well. Here in the vSphere client, if you go to the cluster level with DRS enabled, you'll see this new vSphere DRS widget. It looks much different than it did in previous versions of vSphere, with the predominant features being the new cluster DRS score and the new VM DRS score. So the cluster DRS score is really just an average of all the VM DRS scores running in the cluster. So you can very quickly see, hey, across the board in this cluster, what's the happiness and efficiency level like for these workloads? You can see that our cluster DRS score is 96. So we're relatively quite happy here, getting up close to 100. And then if we look at our individual VM DRS scores, you can very quickly see that there are no virtual machines lower than 80%. And we have 6 virtual machines that are in the 80 to 100% range. Right now we have 0 DRS recommendations, 0 DRS faults. And if we click on View All VMs, this will take us to the Monitor tab. And there's a new section here called VM DRS Score. And this is where you'll see the specific DRS scores for all the virtual machines running in this cluster. In fact, I like to sort right here by DRS score and bring the highest performing DRS scores to the top. Of course, alternatively, you could sort and bring the lowest DRS scores up to the top, helping you find immediately the virtual machines that are experiencing some sort of performance issue. In our case, the virtual machine with the lowest score is down to 95, which honestly really isn't that low. In fact, this is the secondary virtual machine for our VMware fault tolerance pair that we still have running. You can sort by active CPU, see who's consuming the most CPU in the cluster, used CPU, and CPU readiness. CPU ready is the percent of time that the virtual machine was ready, but couldn't get scheduled to run on a physical CPU. So anything higher than 0 here, you might want to take a look at, and anything above, let's say 5%, indicates a major CPU resource contention issue. We also have statistics around granted memory, swap memory, and balloon memory. But to me, the best indicator out of all of these is the new DRS score. It very quickly tells you exactly the level of performance and efficiency, I like to say happiness, that these virtual machines are receiving in the DRS cluster. And again, this is what vSphere DRS is going to use to determine whether or not these workloads should be migrated to another host in the cluster. There's a new vSphere 7 feature called Scalable Shares. And while we're talking about this in our advanced DRS module, it's not only a DRS feature, it's really more of a resource management feature. And I want to give credit to VCDX, Mr. Duncan Epping over at yellowbricks.com for helping me to better understand this new feature. Duncan works in the office of the CTO at VMware and has authored many books on the topic of vSphere clustering, HA, and DRS. And as Duncan talks about this, back in 2015, him and Mr. Frank Denneman, also the co-author of many vSphere clustering, HA, and DRS books, talked about what they called the resource pool pi paradox problem. Along with the DRS team, they actually filed for a patent to fix this problem, and the patent was granted in 2019, and that has become what we now call scalable shares. So really an interesting history, an interesting background. And I want to give credit to Duncan for helping me to understand this because honestly, it can get quite confusing. So how this works is if you create resource pools, for example, a high priority resource pool and a medium, or let's call it normal priority resource pool. You can see the shares in this resource pool are set to normal. And let's go ahead and set the shares in the high priority resource pool to high. So the problem occurs where if we add, let's say, a handful of virtual machines, for example, 4 virtual machines to the normal resource pool, there are 4,000 shares of CPU in the normal resource pool. And with 4 virtual machines, you would end up with 1,000 shares for each virtual machine. On the other hand, in the high resource pool, we have 8,000 shares. But let's say that we had 16 virtual machines. In the 8,000 share resource pool, 8,000 divided by 16, each virtual machine, even though it's high priority, would get 500 shares. So we get 500 shares for a virtual machine in the high priority versus 1,000 shares for each virtual machine in the normal priority. And what that means is that the virtual machines in the normal resource pool get twice as many resources as the virtual machines in the high resource pool. And this is the exact problem that the scalable share patent helps to solve. Now we're talking about this in DRS because if you go into the DRS configuration and edit the config, you'll see underneath additional options, a single checkbox that says enable scalable shares for the resource pools on this cluster. And this is a brand new option right here. And with that enabled, what will happen, you can see here, it says scalable shares are set to scaled. And even though we still have 8,000 shares here and 4,000 shares here, let's just double check. We'll do a refresh. Yep, still 4,000 and 8,000. With scalable shares enabled, the virtual machines in the high resource pool will be much better off. So let me show you how this works. With scalable shares, a resource pool share calculation is made just as it's always been made. However, this time it's going to be calculated differently. First off, you should know that a resource pool to DRS is actually 4 vCPUs and 16 gigabytes of RAM. And high, medium, and low resource pools receive 2,000, 1,000, and 500 shares respectively times 4. That's the calculation that you see back in the vSphere client, where the high resource pool has 2,000 times 4, which is the 8,000 that you see. Now, with scalable shares enabled, the resource pool share is calculated with this formula, where it's 4 vCPUs times the number of pool shares, which in the case of the high resource pool would be 2,000, times the total number of shares of all vCPUs in the resource pool. Now, a single vCPU receives 1,000 shares. So our high resource pool would be calculated as 4 vCPUs times 2,000, because it's the high resource pool, multiplied by 16, which in this case is the 16 virtual machines in the resource pool times 1,000, assuming each one of them just has a single vCPU, would equal 128 million shares for the 16 virtual machines in the resource pool. And then the normal resource pool would be calculated as 4 times 1,000 because it's the medium or normal resource pool times 4 because we said we had 4 virtual machines in the resource pool. And assuming they each have 1 vCPU, that would be 1,000. So it's 4,000 times 4,000, which is 16 million. And the result here would be that the high resource pool would get 8 to 1 as many shares as the normal resource pool. And that's exactly what you would expect. So thanks to Duncan Epping and Frank Denneman at VMware, the resource pool pi paradox problem has been resolved thanks to scalable shares. Just go and enable it with a single checkbox. And of course, while we demonstrated this based on CPU values, this also applies and extends to the resource management of memory in the resource pool and the DRS cluster. Either at the DRS cluster level, here in the configuration, or it can be enabled on the individual resource pools right here with this checkbox that says scale descendants shares. Yes, make them scalable. And of course, you would do that on each one of the resource pools. So congratulations to Frank and Duncan on seeing their idea become a patent and then finally help all of us vSphere administrators. I highly encourage you to enable scalable resource pools in your vSphere 7 infrastructure and up. When we created our vSphere DRS cluster at the Wired Brain Coffee Company in this course, we really just took the defaults. And when it came to DRS automation, again, we took the default of fully automated. But there are other automation levels, and there's also the migration threshold, both of which you should consider in your production DRS cluster. To configure DRS automation, we're here at the cluster level. On the Configure tab, we've selected vSphere DRS, and you can expand out DRS automation to get a read-only view of what's going on right now, how it's configured right now. You can see that we're configured when it comes to automation level at fully automated. That means that DRS places virtual machines onto hosts at virtual machine power on, and then virtual machines are automatically migrated from one host to the other to optimize resource utilization. It's all automatic, just like a robot in the background, shuffling around your virtual machines to get the best performance for your workloads. And then there's the migration threshold. This is a number from 1 to 5 that you configure that tells DRS how aggressive it should be when it comes to taking action. For example, if it sees a host that's just slightly off balance, should it take aggressive action and move one of those virtual machines to another host? Or should it be more conservative and let these hosts get slightly out of balance? Because there is a cost, perhaps a performance cost even, of moving one of those virtual machines over to another host simply to balance the load. In other words, as long as the virtual machines are getting the resources that they need, why aggressively move them around with vMotion, which could in itself have a performance impact? If we click on Edit, we can go in and it's here that we can change the automation level. For example, from fully automated down to partially automated. This is where DRS only places virtual machines onto hosts at power on, but migrations are simply recommendations that would have to be manually approved. And then you have fully manual. This is where DRS really just generates recommendations for virtual machine placement and also recommendations for migration. This is really where DRS is sort of in a read-only recommendation mode. And I would only recommend this if you're just getting started with DRS and you kind of want to see what it might do before you enable it to get a comfort level. And then let's say we go back to fully automated, we have the migration threshold, again, which varies all the way from 1, which is the most conservative, where you would have the least frequent vMotions, up to 2, 3, 4, and all the way up to 5, which is the most aggressive or the most frequent vMotions. It's going to take aggressive action to keep the cluster in balance. Most people seem to put the slider right in the middle at a 3, use fully automated as soon as they gain a comfort level, sit back and relax, and just let vSphere DRS take care of any potential performance problems, typically preventing them before they happen. So that's what you need to know about automation levels and migration thresholds. And this also brings me back to the new DRS score, where vSphere DRS has been redesigned to focus much more on the workload instead of simply trying to balance the clusters. So in my opinion, vSphere 7 DRS is far more reliable than ever before, and I wouldn't have any problem at all keeping my cluster at a fully automated automation level, and likely, like most everyone else out there, leave the migration threshold right there in the center, somewhere between conservative and aggressive. With vSphere DRS, you can create host and virtual machine groups, and then you can create rules around these host and virtual machine groups. The end result is that you have a lot of flexibility when it comes to affinity rules. In other words, keeping virtual machines together or keeping virtual machines on specific hosts, or anti-affinity rules, meaning keeping virtual machines apart. But there's a lot to consider when it comes to affinity and anti-affinity rules. For example, say that we have 4 ESXi hosts, they're in a DRS cluster, and we have a few virtual machines, 1 on 3 out of the 4 hosts. These are moving around with DRS as needed. However, if we have anti-affinity rules in place, DRS will be told that it can't place specific virtual machines together on a single host. This is called a VM to VM anti-affinity rule. Let's say that you had a highly available SQL Server cluster. It's made up of 2 virtual machines. However, you don't want the same 2 virtual machines that are in a synchronous, high available cluster. However, you don't want these 2 virtual machines that are in a highly available cluster running on the same ESXi host, because if that host fails, then both virtual machines are going to fail at the same time and have to be restarted. So that's an ideal use case for a VM to VM anti-affinity rule. And then we can also have VM to VM affinity rules, where DRS realizes that based on this rule, the virtual machines should not be apart. From there, it can take action and it can put the virtual machines together based on the affinity rule that you created. And then we have what are called VM to host anti-affinity rules. You might configure these to keep a virtual machine from running on a specific host. And then you could also configure VM to host affinity rules to pin a virtual machine, as they say, or to keep a virtual machine on a specific host. Now let's go to the vSphere client and I'll show you how to configure affinity and anti-affinity rules. Configuring VM to host and VM to VM affinity and anti-affinity rules for vSphere DRS is easy to do. Here in the vSphere client, this is really done in 2 different places. First off, you can go to the VM host rules section on the configuration tab for the cluster, and it's here. If you just have individual VM rules, for example, you could keep a rule to keep virtual machines together, like keep web servers together. You could click add. We could select our web servers, click OK, and it tells us that these virtual machines will be run on the same host. I'll click OK. And we just created our first affinity rule. So this is a VM to VM affinity rule. Keep these web servers together. We could also easily create another rule called keep SQL servers apart. And this would be of type separate virtual machines. So this would be a VM to VM anti-affinity rule. And here I could select, for example, a couple of virtual machines, and we'll say that these are our SQL servers. Click OK. And then we just created our first VM to VM anti-affinity rule. And if we go to monitoring and to vSphere DRS history, you might see the results of these rules taking effect in the history. And you might see vSphere DRS migrating virtual machines where they need to be. If we go back to the Configure tab, in order to create rules pertaining to hosts, you need to first create a host group. And you can also create VM groups, by the way. But first, let's create a host group, and let's call this gold hosts. This is going to be a host group, and we'll add a host to it. In this case, it's just going to be one host, but of course you could have multiple hosts in the group. That's the whole point of the group. I'll click OK. So we created a host group, and then let's say we create a VM group, and we might call this Tier 1 apps, and then we'll add our Tier 1 app virtual machines into this group. I'll say OK. And now with the host group and the virtual machine group, if we go into the VM host rules, click to add a rule, and this is where we can start creating virtual machine to host rules. For example, maybe we want Tier 1 apps on gold hosts, and we could say the virtual machine group Tier 1 apps must run on hosts in the group. Other options are should run, must not run, or should not run. And then the only group we have available so far is the gold host group. So the Tier 1 apps must run on the gold host group. I'll click OK. And with that, we just created our VM to host rule. Of course, you can also create the last rule type on the list, virtual machine to virtual machine. In this case, you could say the virtual machine dependency restart condition must be met before continuing to, for example, Tier 1 apps. And if we go over to monitor and to history, you can see that based on one of the rules we created, SQL Server Windows 1 was migrated from Node 1 to Node 2 in order to meet our rule that we defined to keep the SQL servers apart. So I think now if we go to the virtual machine tab, we've got SQL Server Win 1. Let's add in the related objects here, and you can see that this is running on host Node 2. And then we said that log Win 1, this fell into our SQL Server group, and you can see that it's running on Node 1. So vSphere DRS took action to separate these two virtual machines that made up the SQL Server group, running them on separate nodes in the vSphere DRS cluster. So that's how easy it is to create VM and host groups, as well as VM and host rules. Announced back in vSphere 6.5 was something called predictive DRS. So what is predictive DRS? Well, DRS, if you think about it, is actually reactive. It recognizes that a vSphere virtual machine is having issues, its workload is not getting the resources that it needs, and it's unhappy. And according to the new vSphere 7 DRS score, there is a problem. And at that point, DRS will take action to resolve it. However, it cannot take action to resolve it before the problem happens. However, with vRealize operations and vSphere DRS together, you can enable what they call predictive DRS. And while predictive may sound better, in reality, you need both reactive and proactive. You need DRS and you need this new predictive DRS as well. That's because predictive DRS isn't going to be 100% accurate. It's going to help to identify virtual machines that may very soon have a problem. However, you also need DRS so that once virtual machines already do have a problem, if they weren't caught by the predictive algorithms in vRealize operations, it's then that DRS will take action as well. The best approach here really is a balanced approach between using both DRS and VROps predictive DRS. Here in the vSphere client, you'll find that it's super easy to enable predictive DRS. If you go to the cluster, to the configure tab, and then into vSphere DRS and click on edit, enabling predictive DRS is as complicated as checking that box right there. Now, what they don't tell you is that this requires vRealize Operations Manager to already be up installed and running. So make sure that your version of VROps and your version of vSphere support predictive DRS. So if you're using vRealize Operations, I encourage you to enable predictive DRS. And if you're not, then I encourage you to begin using vRealize Operations and pair it together with DRS to really create here the ultimate combination, both predictive and reactive workload optimization.